Link aggregation, ether channel. We're looking at now, we've got connections between multiple switches, and instead of just paying lots of money to increase the bandwidth between your connections, we can now do it for free. We just grab a couple of ports at each end, and we go from a gigabit uplink to a 2 or a 3 or 4, anywhere up to 8 gigabit connection between two switches for free, because you've already paid money for the ports. So you just bundle up multiple physical interfaces into a single logical connection. So ether channel interfaces are done, creates a virtual interface, and all your commands are done on that. No need to upgrade the physicality. It load balances. It does a load balancing across the channel itself. As far as spanning trees, we just looked at spanning trees. Spanning trees concerned, it's a single interface, and there's redundancy. Let's say you got 2 or 3 physical connections in an ether channel bundle, and if one of those fails, the other 2 just pick up the slack like nothing happened. So it's actually pretty good for redundancy as well. There are a few caveats and restrictions. For example, the maximum amount of physical interfaces per logical bundle or group is 8, and some of the smaller switches, so it's going to the material and your chapter exams, only support 6 ether channels, because where most of the CCNA looks at the 2960 series of switches. However, if you do go on to bigger 37s and 38 series switches, they do support more, but for the sake of your exam, there's 8 ports per channel and a maximum of 6 channels per switch. So, like all good standards, there are 2 of them. We have, the first one is Port Aggregation Protocol. This is Cisco proprietary, and it has a series of keywords to enable it. So if you say channel mode on at both ends, it's just on. It's hard on, and there's no negotiation. If one end is desirable and the other end is desirable, it'll come up. If one end is desirable and the other end is automatic, it will come up. If one end, all other combinations, it won't work. So you've got 3 keywords for port aggregation protocol, is either on, desirable, or auto. So for example, if both ends are auto, it will not negotiate into an ether channel bundle. Link aggregation control protocol is the open standard. So if you've got a Cisco device and a non-Cisco device, or a VM server, or some sort of Linux box, or adapter teaming on a Windows box, you'd want to use LACP instead of PAGP. So on is on, same as before, but instead of auto and desirable, now we have active and passive. So active on, active passive on, but if you have passive and passive, then you won't get, the bundle won't form. And if you have on in any other state, it won't form as well, because just like in PAGP with desirable and auto, active with passive, they'll only ever listening. So with auto in PAGP, it's only ever listening. It's a bit messy, but I'm hoping that it might sort of, give a bit of a clue. So PAGP is auto and desirable. LACP is passive and active. So you can see that passive and active, or active and active, yes, or auto and desirable, or desirable and desirable, yes, and on, yes, and all other combinations are not going to form a normal ether channel bundle. Speed and duplex must match. This is very, very important, because the devices use CDP neighbors to talk to each other, and if one end is half duplex and the other end is full duplex, or the VLANs are on the wrong VLAN, or the native VLAN is mismatching, these are all the things that are going to stop an ether channel forming. So you always need to make sure that both switches, both the interfaces that you're grouping together, are identical at both ends. So how do we do it? Well, interface range, fast Ethernet 0/1 to 2. Channel group is the command that actually creates the channel. The number 1 represents the virtual interface that we're creating, and then the mode. So we've got 5 choices. We've got on, we've got active or passive, and we've got desirable and auto. So this example we're doing LACP, so we're using active. And now notice the very second that you press enter on channel group mode active, it creates a virtual interface. It says I've just created port channel interface number 1. And then you change that interface and then you put your commands. So if you put in 5 commands in the virtual interface port channel 1, those 5 commands will automatically appear on fast Ethernet 1 and fast Ethernet 2. Now this is why it's meant to work. Unfortunately, in the real world, sometimes it's a good idea to set up fast Ethernet 1 and 2 with every command you need and make the very last command channel group 1 mode active, because sometimes the commands don't bleed from the physical interface to the virtual, and vice versa. Sometimes if you go into that interface after you've made the channel, it'll actually give you a warning and say, stop, you've made me into a port channel. If you want to make any changes, you should go interface port channel 1 and then make those changes. So in the labs, you should follow it this way, but just note in the real world, sometimes you need to just double check that if you've made a change in the physical, it's represented in the virtual, and if you made a change in the virtual, it's represented in the physical as well. Show commands, show interface port channel, show ether channel summary. Ether channel summary is probably the command you'll be using the most because it gives you a nice little summary. See down the bottom here, we've got port channel 1. It is currently S and U, so therefore it is a layer 2 connection and it is in use. The protocol is LACP, and ports FA0/1 and FA0/2 are currently actively in use, bundled in that channel. So show ether channel summary, very useful command for verifying your ether channel. So once again, problems. On the left hand side we've got channel group mode 1 on, and on the right hand side we've got channel group 1 mode desirable. Now, as we talked about before, channel group mode 1 desirable and channel group mode 1 on shouldn't work, and it won't work. So you need to think to yourself, well, which one do I need to change? Now, years ago, I was a big fan of channel group mode 1 on. So I'd force all of my interfaces to be on, but then you've got a little bit of a risk of spanning tree. Because if you plug it in and the switch 2 is just blank, that will actually make a loop, because it'll be 2 ports on 2 and 1 port on 1 and cause a loop. So I'm sort of leaning towards saying that switch 2 is actually correct. So channel group mode 1 desirable is actually better, because if the channel doesn't form, then spanning tree will just treat interface 1 and 2 as separate interfaces and you won't get a loop. But then when the channel comes up, then they'll logically bound into a single interface, and then spanning tree again will be happy. So different schools of thought, but I'm pretty sure that channel group 1 mode desirable is probably a better way of fixing this problem. A safer way. Thank you very much. See you on the next one.